Hello secondary 1. In this video we will explain lesson 2 in unit 5, and it is talking about the strong nuclear force inside the nucleus. So please pay attention, it is a very important lesson. Here inside the nucleus, we knew that the nucleus contains two different particles, which are positive protons and neutral neutrons. There are many forces inside the nucleus of the atom. Number 1, repulsion force, and this repulsion force between the similar particles such as protons. So between each two protons, there is a repulsion force that try to move each particle away from each other, and this is considered as a force. And the second type of force here, the attraction force, and the attraction force between different particles inside the nucleus and the different particles inside the nucleus, which are positive protons and neutral neutrons. So there are many forces inside the nucleus, which are number 1, repulsion force between positive protons, and binding force or attraction force between positive protons and neutral neutrons. Okay, let's see the properties of these force. Properties of strong nuclear force inside the nucleus. Number 1, it is a great force. For sure it is a great force. It's greater than the gravitational force. Okay, if it compared with the gravitational force, the nuclear force is greater than the gravitational force, for example. B, it is short range force. Short range force means this force works only in a specific position or in a specific situation. Okay, so this force has a short range. Short range means that these forces works only when the space between the nucleons inside the small nucleus is very small. Again, B, it is a short range force by meaning of it works only when the space between the nucleons inside the nucleus is very small. Okay, what's meant by nucleons? Nucleons means the particles inside the nucleus, which are positive protons and neutral neutrons. C, it doesn't depend on the type of charge of nucleons. It may be between proton and proton, neutron and neutron, and these are repulsion force, as these are similar charging. And the force between protons and neutrons, and this is called attraction force or binding force. So again, the properties of a strong nuclear force. Number 1, it is a great force. B, it is a short range force, as it works only when the space between the nucleons inside the nucleus is very small. Okay, and it doesn't depend on the type of charge. Okay, here I have, for example, helium element, and this is the proton of element and neutrons. As we know that the helium, He, it contains 2 protons and 2 neutrons. Okay, if we calculate, pay attention, it's very important point. If we calculate the sum of mass of 2 protons and 2 neutrons, and this is called theoretical mass. Again, if we calculate the mass of 2 protons and 2 neutrons, 3 protons and 3 neutrons free after binding together, okay? If we calculate the summation of their masses, we find that the sum of masses of 2 protons and 2 neutrons are 4.03188 AU, which is atomic unit. This is the measuring unit of mass for any atom, for very small particles, and this is called theoretical mass. Then when we calculate the mass of the nucleus of the helium, it contains also 2 protons and 2 neutrons, but here after binding together. Here no free protons or free neutrons. Here after binding together. The mass will be 4.001503 AU. We can conclude that the mass of free protons and free neutrons is greater than the mass of the protons and neutrons after binding. And after binding is called actual mass. This is actual mass. So here there is a mass defect. Pay attention. The theoretical mass is always greater than the actual mass. Theoretical mass is always greater than the actual mass. As there is an amount of mass that relays during binding these particles together in a form of energy. As you know, to form any bond between particles must release an amount of energy. Okay, pay attention again. Here the actual mass and here the theoretical mass. If we calculate the theoretical mass of 2 protons and 2 neutrons that are in helium, we found that their value is 4.03188 AU, atomic unit. Okay, and this is theoretical mass. And when we calculate the mass of them, but after binding together, we will find that their value will be 4.001503 a unit, and this is called actual mass. Okay, pay attention again. The theoretical mass is always greater than the actual mass. Why? Because there is amount of mass change into energy, release in a form of energy during binding these particles together. Okay, so here we have mass defect. To calculate the mass defect equal theoretical mass minus actual mass, and this is very important rule to solve your problem. Mass defect equal theoretical mass minus actual mass. Okay, by using Einstein equation, we can calculate the binding energy. As we knew before in the previous lesson. The Einstein equation told you that the energy in million electron volt equal the mass in unit multiply a constant number, which is 931. And here I can use this equation to calculate the binding energy by the same equation. To calculate the binding energy in MeV, million electron volt, equal the mass defect in U unit multiply a constant number which is 931. So this is the second important rule in this lesson. Okay, there is another binding energy. I can calculate the binding energy per nucleon, per one nucleon. Nucleon here means one proton binding to one proton binding to one neutron. Okay, I can calculate the binding energy per nucleon by dividing binding energy, total binding energy, divided by mass number, which is estimated by letter A. Okay, so here there are very important three rules that very important to solve your problems. Pay attention again. Mass defect equal theoretical mass minus actual mass. For example, if I want to calculate the mass defect in helium atom, so the theoretical mass is 4.03188 minus 4.001503, and the mass defect here equal 0.03038 unit. Okay, I can use the mass defect here to calculate the binding energy. So the binding energy from the Einstein equation equal the mass defect multiply 931. And if I want to calculate the binding energy but per nucleon, equal the binding energy divided by the mass number of the element that I want to calculate the binding energy per nucleon. Okay, let's see a problem to explain more for this point. Problem number 1. Calculate the nuclear binding energy in MeV for the helium nucleus. Then calculate binding energy per nucleon, knowing that the actual mass of helium is 4.00150 unit and the mass of proton is 1.00728 unit and neutron mass is 1.00866 unit. Okay, number 1 here, I need to calculate the binding energy. The binding energy equal the mass defect multiply 931. So firstly I must calculate the mass defect. The mass defect equal theoretical mass minus actual mass. The theoretical mass here, you must know that the helium contains 2 protons, that is written in lower number as you see helium 2 4. So the number of protons here is 2 and the number of neutrons here is 4 minus 2, so equal 2 neutrons. So to calculate the theoretical mass, here I have 2 protons, so I must multiply the value of the mass of one proton, which is 1.00728, plus 2 neutrons, multiply its mass, which is 1.00866. And finally the theoretical mass equal 4.03188 unit. This is the theoretical mass. And here I have in the given the actual mass, so I can calculate the mass defect by subtract theoretical mass minus the actual mass. And the value of mass defect equal 0.03038 unit. Okay. Then I can calculate the binding energy. It's so easy. Binding energy equal mass defect multiply 931. So the mass defect equal 0.03038 multiply 931, and the value of binding energy equal 28.28 378 million electron volt. And by using the binding energy, I can calculate the binding energy per nucleon, per one nucleon, okay, equal the binding energy divided by mass number. The binding energy here equal 28.28 to 378 divided the mass number of the helium is 4. How can I know the mass number here? Yes, he gives you that helium 2, 4. The lower number is atomic number and the upper number is mass number. So the mass number here is 4. By dividing, yes, so the value of binding energy equal 7.070 945 million electron volt.